Talk about it right now. Let's go. Let's go. All right. Now, anybody have any questions solving the other ones? All right, through 17, because we kind of set them up. Yes. All right, so we got to set up 18, and we have to set up 19. All right, so here we go. Let's take a look. Yes, sir. Yeah, let's go. Tell me about 18. Well, I want 18. And what did I say 18 was? That asterisk was?
8.
I think it was 8. Did it work out right if you solved it? All right, so I think it should be 8. All right. What was it?
4A plus 6B equals 16.
4A plus 6B equals 620. I don't think that's that hard, right?
And you multiply the bottom equation by -2.
Multiply the bottom equation by -2.
And you end up with -10b equals -5.
So what was B?
0.5.
So is B, anybody else get 1/2 or 0.5?
Yes.
So it would be 50 cents, right? Per what? Per kilogram? Yeah. What's the matter?
I multiplied the top one by -2, but I still got 0.5.
Wait a minute. If you multiply the top one by -2, you get -8 and -12.
Okay. Divided.
Yes, you can divide by -2.
Yeah,
That's a
okay.
good job. You can definitely do that.
Okay.
All right, I think that's actually a great way to do it. All right. And so if B was 50 cents per kilogram, then A was what? 80 cents? What? We didn't. Did you add them after you multiplied by -2 or not? Do you have your iPad today? So are you looking at your iPad? Okay, did you multiply by -2? And then what happens when you add them? Charlie, where you been? Come on. Right up here's the spot. Where have you been? Okay, let's go. Okay. All right. Now, 19. A boat can travel 16 kilometers per hour against a current. The same boat could travel 30 kilometers per hour with the current. Find the rate of the boat. Well, how do I set this up? With what? Let's let someone tell you. All right? Sam, how do you set this up?
16.
No, I want to tell me. Wow. The boat minus the current can travel 16 kilometers per hour. How is that? I don't know how fast the boat is, and I don't know how fast the current is. But I know how much the boat and the current is, and I know how much the boat minus the current is. Do we agree with that? Anybody have any issues with that? And how easy is that to solve, right? Super easy. Super easy. It's the what? Setting it up. All right, so that's what we're practicing. All right, let's move on. 20. Everybody read 20 now. and set it up. I like it. Go. The jet plus the wind is 1100, and the jet minus the wind is equal to 750. How easy is that? Come on, you should be getting better at it. All right, you really should be getting better at it now. All right, that's number 20. You've done 20 examples. All right, now that's easy to solve. Does everybody agree? All right, let's go on. 21. Okay, this one's a little bit harder. I think you'll like this one. This one's kind of tricky. Tell me.
Back on 20, when it's telling you like what to find, what does it mean of the jet is still there?
So like when you're, believe it or not, when you get on an airplane and fly, or even in your car, right? If you go, and you even know this if you've ever done some jogging outside or something. If you're going with the wind and against the wind, you're going a lot faster when you're running what? With the wind. And if you ever try to run against the wind, right? Or if you've ever been in a boat and it's windy and you're going with the wind and you're going against, right? A better example of this would be even walking up an escalator. When you walk up an escalator, it looks like you're going what? Really fast. And you see those knuckleheads who always try to walk down the up escalator, right? Yes, like I said, I know, number one, right? Maybe that's me right here, right? Trying to walk. All right, and so what happens? They're going against each other. So you can actually walk and not go anywhere. Same thing with like a treadmill. All right, that's what's going on. All right, so if you go and you see somebody fly off the treadmill, right? They're going really fast, right? So again, that's what we're talking about, right? So if you get in your car and you're going 50 miles per hour, it might say you're going 50 miles per hour, but if you're going with the wind, you're actually going faster than 50 miles per hour. All right, so we're all good with that explanation? All right, now let's see if we can set up 21. Yes, let's hear it.
Is it S plus C equals 24 and S minus C equals 40?
So what is S though?
Swimmer.
What is the swimmer doing?
Swimmer.
Okay, so here's what I want you, I want everybody to try to think about this for a minute because this one's harder, no doubt about it. So when you say the swimmer is what? Swimming,
yeah.
Right? So if you say, tell me what you thought it was?
Swimmer.
S what?
Oh, S plus C equals 24. S minus C.
Okay, so hold on. So the swimmer, what exactly does, I mean, this is minutes, right?
Yeah.
So you're telling me that the swimmer in the current is minutes. So you got to think about that, all right? We have to convert them to what? The same units. Like up here, the jet was traveling at a certain kilometers per hour, and the wind was a certain what? Kilometers per hour. So this over here is a what? Kilometers per hour. So we agree with that now? All right. So down here we have a little different problem.
Would it be 4 plus C?
So what do we want to define C as? Yes, eventually that's what we have to do. All right. So what do you think?
24 plus C equals 4.
So a minute can't equal a kilometer. What do you think?
S plus 4C equals 24.
So S is minutes? That's what I'm trying to say. All right. What are you thinking?
I was going to say S plus C equals 4, but
Because S then is a distance, right? What?
4 plus C equals
All right. I think I got to help you with this. And again, like I said, I think this is hard. So give it one more shot.
S equals 40.
All right. So here's something. What?
4S plus C.
4S. Stauffer, go ahead.
4 plus C equals 24, and 4 minus C equals 40.
So 4 plus C equals 24. So 4 kilometers plus S is equal to 24 minutes. Right, this is what I'm trying to tell you. This one's a little bit harder. So let me start out by saying this. All right, there's a relationship between a distance, between a rate, and between a time. What's the relationship? Yes. So come on, distance, rate, and time. What's the relationship from your science class, maybe? Distance is always equal to what? Rate times time. Distance is equal to rate times time, so you definitely need to know that. Right, so for example, if you are traveling at 50 miles per hour for 2 hours, you've gone how far? 100 miles. You intuitively know that, right? That's what that is. Distance equals rate times time. Everybody agree with that? All right. So let me erase this and see. Like I said, this is one that's a little challenging, so stay with me. All right. So a swimmer can swim 4 kilometers with the current. So do we know how fast she's swimming?
No.
Well, we know she's go. How fast is she swimming? Who said yes?
Oh,
How fast is she swimming? Do we know?
no.
No. How do we know?
6 kilometers.
So here she is. Here's watch. Here's what I'm trying to show you. Here's the water. All right. And just because I can't draw, there she's swimming. All right. Now the current is going in this direction. And she's swimming in this direction. And it takes her what? It takes her 24 minutes to travel this 4 kilometers. All right, so here she goes. So she's over here. It takes her 24 minutes. All right. Then all of a sudden she turns around and she swims back. How long did it take her? Why? Going against the current. So how do we know how fast she's swimming? We don't. Do we know how fast the current is? No, we don't. Do you agree? Right? But what do we know? We know that the current rate and her rate, all right, if I add them up, that's how fast she's going with the current. Do you agree with that? Right? So here's what I'm trying to tell you. So now let me move this out of the way a little bit. Hopefully you visualize that pretty good. Or I should say a little better anyway. All right. So do we know how fast she's swimming?
No.
No. How fast is the current? We don't know, but she's swimming with the current, right? Right? And it takes her how much time? It takes her 24 minutes, right? And then that will be how far? 4 kilometers. All right, that's important. All right. What? Because I'm just multiplying it. It doesn't really matter. What? Yes, that's what we just said. All right. So
Oh,
now the second equation. Someone help me out with the second equation. All right, Mr. Stauffer.
in parentheses s minus c, and then in parentheses next to it 40 equals 4.
What do you guys think about that?
Yeah.
That makes sense, right? Again, I wouldn't expect you to know how to do that. I wouldn't expect you to go, wow, okay, that kind of makes sense now. Right? Distance equals rate times time. All right, that's the relationship. Yes, ma'am.
Why did we put car again for the second one?
Well, how far does she swim?
She swims back.
Right? She swims the same distance. Right? Okay, so now, because we have a calculator, right? Does everybody agree? I would like to just put S plus C equals 1/6, and S minus C equals what?
1/10.
I think that's easier. Does everybody agree with that?
Oh.
Come on now, don't ask me how I got 1/6 and 1/10. Come on. Look up there. Figure it out. Right? Everybody good with that? Now, what can I do? Now, we're not using our calculator now, please. I want better mental math. That's what I'm trying to get you guys at. All right? It would be different if, like, the rate of the planes were thousands, right? I don't care about that. But we want to make sure we can do fractions, correct? So, help me out here. If I add them together, everybody should do their mental math here. No work involved. We would have S plus S. What's that? 2S. Now, everybody hold up for a second. Now, if I say 1/6 plus 1/10. Come on, everybody look at that. Common denominator is what? 30. So the top fraction is going to be how many 30s?
5.
And the bottom is? Altogether, that is?
You say 9.
That's all right. Don't worry about it. It's all right. All right. I messed up on 5 plus 3 a long time ago, too. 5 plus 3 is what?
8.
8 over 30 can reduce to?
4/15.
All right. So, 4 over what? 4 over 15. Does everybody agree with that? Now, I'm going to divide by 2, which is embarrassing. A lot of people can't do 4/15 divided by 2 in their head. What is that? Obviously. 2/15, right? You're taking half of 4. Half of that fraction. If you have 4/15 and I said, what's half of that? You would tell me it's what? 2/15. All right, so now S equals 2/15. Now, we would say 2/15. I want to see if somebody can give me the units. It would be 2/15 what? Come on now, you got to think before you say something. Mr. William. Kilometers. Say it. Kilometers per minute, right? Because that's the rate. S is the rate. So again, 2/15 what? Kilometers every what? Every minute. So that's the swimmer. All right. So now, if the swimmer was 2/15, so now I want to put 2/15 into here. We're practicing our mental math again. So 2/15 plus the current is 1/6. So now it's 1/6 what? Minus 2/15. So everybody help me out. 1/6 minus 2/15. Common denominator again is 30. So how many 30s is 6?
5.
And how many 30s is 15?
4.
So altogether,
1/30.
how much?
1/30.
1/30th in my opinion. So we have the current is what? What is it? Come on, before you say something, remember I said think. What did we just say it was? 1/30th kilometer every what? Every minute. All right? Is everybody okay with that? Now, let's see if we're right. Let's see if we're right. So, if the swimmer and the current are going together, how fast would they be going?
2 kilometers an
No. Someone help him. All right. If the swimmer is 2/15 kilometers per minute and the current is 1/30th a minute, then if you're swimming with the current, you're going how fast? How are we getting that? Well, that's what I'm saying. Come on, guys. I don't care about the calculator. Practice your mental math. All right. If I said you're going the swimmer plus the current, you should be able to tell me pretty confidently what 2/15 plus 1/30th is. Is everybody okay with? What are you saying? Add them together. What do you get when you add them together? I want to hear. How did you get that? Now, I'm not asking. I'm saying I'm adding 2/15 plus 1/30th. If you don't know how to add the fractions in your head, I need to help you with that. What's the common denominator? 30. So if I'm doing 2/15, I'm going what? 4/30 plus 1/30 is 5/30, which reduces to what? Come on, that's good mental math exercise. You should be able to tell me together they're traveling at what? 1/6 of a kilometer every what? Minute. And how long is she going to be traveling with the current? So if I'm traveling at 24 minutes, 24 times 1/6 is what? 24 divided by 6 today is 4. You guys are killing me. I say we cancel Thanksgiving to meet with mental math practice. All right. Does everybody see how that works? Right. And if I'm going against the current, Morty, how fast am I traveling against the current?
That's a lot.
If I'm traveling against the current, let's do the mental math. 40/30ths. What? I'm traveling against the current. Will you please subtract S minus C? What is it? How did you get that? Shh. I want to hear this. Speak up loud and proud. I want this on tape. I want your parents to go, wow, my kid knows how to subtract fractions.
Minus 1/3 equals 1/10.
Well, okay, I wish it was.
3/30ths, which is simplified to 1/10.
Yes, 1/10. All right. So going against the current, you're only traveling at what? 1/10 of a kilometer every what? Minute. So now, if I'm traveling at 1/10 of a kilometer in 40 minutes, I will go how far? 4 kilometers. Wow, thank you. 40 divided by 4. And now I can see we need help with some mental math, especially on fractions. All right, so I might print out a worksheet on mental math for fractions. That was kind of embarrassing, to say the least. All right. All right, here we go. Let's try 22. Let's let the fun continue. What I thought, Sam. Here we go. A plane flies the first half of a 5,600 kilometer flight into the wind, all right, is 3.5 hours. The return trip with the same wind takes 2.5 hours. Find the speed of the wind. All right, hold on. I think I made a typo in here somewhere. All right, let's yeah, my secretary again. Let's skip 22. Stop. You should be. Oh,
No, guys, we
Dawn.
should be
All right, thank you. I like that. All right, much better. Saying good, we skip a problem. That's embarrassing. All right, 23. All right. All right, let's see what's going on here. A plane has a speed of 840 kilometers, so that means the plane can fly 840 kilometers per hour. So everybody agree with that? All right, but it says it can travel 3,120 kilometers with the wind. In the same time, it will take to travel 1,920 kilometers against the wind. All right. Now we have a problem. All right, so again, I think it's important that everybody write distance equals rate times time. So, how fast is the plane flying? All right, so then it says it can travel 3,120 miles with the wind. All right, so how far will it go? 3,120 is equal to, how fast is it going? 840 plus, that's right. 840 plus the wind. And how much time is it flying? We don't know, so you would say it is? Why H when we're talking about time?
T. I was thinking hour.
All right, I like that explanation. I like that. All right, so now, going against the wind, are we going a shorter amount of time, or a shorter amount of distance, or longer distance? Shorter distance. So how far are we going? 1,920 is equal to, somebody help me, 840 minus times what? Times T. All right, so we'll start by this one. This is a really good one. All right, we can do a couple things here. I think we should distribute the T. All right, let's distribute the T. So it would be 3,120 equals 840 T plus WT, and then 1920 is equal to 840 T minus WT. Did everybody see that? So what do you think I should do now? That's a 40, by the way. What should I do with these? That's right. So what do I have to do, though? You just add them, right? Now, the nice thing about adding them is what happens to the WT? They cancel out. All right? So I want someone to tell me what T is equal to. You can use a calculator on that. So how much time is it going to take? Yep. Come on. I just want the answer. Everybody's using the calculator now. No. I want the final answer. T equals what?
6.
Thank you, sir. T equals 6. I'm not sure if he's right, so let's verify that. Anybody else get T equals 6? Don't sit around and put 6 down. All right, because Mr. Wilson said the answer was 6. Your job is to do the math yourself, not just write the answers down. All right, that's part of the problem for some of you, just writing things down. All right, when we tell you the answer, you're just writing them down. How do I get 6?
I got 3.
Somebody said 3. 3.
6. 3. It can't be.
How do we verify this? What do we do?
Oh, I don't.
I'm just asking, how did you get 3?
Oh, well, I added 840 to 840.
And?
And then I added 3,120 to 1,920.
And then?
I divided the numbers.
Beautiful. And so the answer is?
3.
Anybody else get 3?
Yes. I got 3.
All right. Those you guys. All right.
Well, you probably didn't add 840.
840 plus 840. You have to make sure you do that, right?
Yeah, that's why.
All right. Now I want to read what it says. All right. It says for us to do what? It says find the speed of the wind. Right now we have what? Time. So now, what I'm doing now, guys, please look. I need to figure out what W is, right? So the easiest thing to do is to plug 3 right into here. So now, let's not write anything down because we're brilliant. All right, if T equals 3, how do I figure out what the wind is? What can I do to figure that out quickly? What? You raised your hand and you're saying, what?
Substitute 3 into T and then distribute.
No, even better.
Divide everything 3 by 3.
Yeah, divide this by 3. All right? 1,040. And then subtract what?
840.
Which is
200.
200, I believe. All right? So you would say the wind is going at 200 kilometers per hour. All right? 200 kilometers per hour. All right, that's what I'm talking about. All right? If you plug 3 in, you could distribute. Does everybody agree?
Yeah.
Yeah, but I want to make sure that you understand we can just do what also? Divide by 3. Does everybody agree with that? What? I solved that. Take your calculator out. Do 3120 divided by 3 equals. Subtract 840. You with me? So I replace this T with a what? With 3. And now I'm just solving that equation. You agree? Divide by 3, subtract 840. That's how I want you to be. All right. Here we go. Let's check out 24. Well, it's kind of the same thing, so hopefully I showed you something. You can set this up a little better now. Come on, guys, remember, you have to try. All right? You have to try. All right, Hannah, set the first one up for me.
So 66 is a distance. 66 is
Right.
Is it 66
Now, let me think about it for a second. A rowboat can travel. So say it again. Now remember, you're in the water. Your current is going this way. Your boat, right, that you're in, is traveling this way too, right? So how fast is the boat going? Do we know? How fast is the current going? We don't know. So if you're going with the current, it would be. That's right. So it'd be, if I'm not mistaken, the boat plus the current. Do you agree with that? And then how long are you traveling with the current? That's right. Times 3. Do you agree with that? All right. Next one.
33 equals
Everybody okay with that? And now what could I do? I can't add them yet.
divide everything by
Yeah, I think we should divide everything first, right? So everybody good with that? And then solve it. That's no problem. All right. Oh, yeah. I want to do 25, and then we'll call it a day. All right, here we go. So it says a 2-digit number is 4 times the sum of the digits, and the tens digit is 3 less than the units digit. What is the number? So first of all, how many digits are there? Can you tell me?
9.
How many digits are there altogether?
2.
No. How many digits are there? How many? 10, right? There are 10 digits. 0 to 9. All right? There's 10 digits, right? Now, we're creating a what? A 2-digit number, right? Now, the 2-digit number is 4 times the sum of the digits. All right, and the tens digit is 3 less than the units digits. All right, so we're going to try to now create a system of equation. Yes.
X, Y, like the 2 digits.
Yeah, so let me I wouldn't expect you to know this. All right, so I want to jump in here, right? So I want to remind everybody, this right here, 32. That's the number 32, but what really does that number mean? What does 32 mean? What? Well, no, I mean, the digits are 3 and 2 themselves, but how do I know that that means 32? Because in our decimal system, right, the second place is the number of what? Tens, and the first place is the number of ones. So this number actually is 3 times 10 plus 2. Did everybody see that? So when I say a 2-digit number, how do I represent any 2-digit number? We would say that it is 10t plus u. All right, and like I said, I'm not expecting you to know that. I'm expecting you to go, wow, okay, I understand that now. So that represents any 2-digit number. If I said t was 5 and u just as a units, right? That just means the 1 spot. All right, so when I say a 2-digit number, listen to what I'm saying. A 2-digit number is 10t plus u. Right? That's literally what 32 means, right? Now, what?
But how do you know that specific number?
I've just made 32 up.
Oh, okay.
If I said 57, that would be what? 5 times 10 plus 7. Right? So if I say a 2-digit number now, and I'm trying to represent the numbers would be written as 10t plus u. Everybody with me? So t represents the digit in the tens position, and u represents the units in the, or the digit in the unit spot. All right, like I said, I'm not expecting you to know that. All right, so now it says a 2-digit number. So there's your 2-digit number is 4 times the sum of the digits. So that would be 4 times what? No. Listen, 10t represents the number itself. The individual digits represent what? T and u. Everybody with me? So it would just be 4 times, yes, 4 times t plus u. Now the reason why I'm doing this one, I did see this recently on a ACT and an SAT question. All right. So again, I'm not expecting you to know that, but I am expecting you to go, okay, that's kind of what that means. A 2-digit number. If I said a 3-digit number, it would be 3, or it would be 100h plus 10t plus u, right? All right. So now, the tens digit. So what does the tens digit represent? No, it's referring to the digit. Just t. Is what? How do I write 3 less than the units? Yes, u minus 3. Just like that. Does everybody agree with that? All right. So I think that's a good stopping spot. Now listen, I'm just telling you, I'm expecting you guys to have these worked out. Does everybody agree with me? I'm helping you set them up because I know that's the hard part. Tomorrow, all we have to do is finish up. And then, believe it or not, this was going to be the other half of your quiz. All right? So I'm going to ask you to submit this work to Google Classroom like you did before. And if you haven't quite got it done, maybe I'll say it'll be due on Monday or whatever we get back or whatever if you want to. But look, guys, I cannot tell you the importance of doing these. All right? I cannot tell you the importance. So your job is to have finished them up, right? I'm setting them up. We know how to solve systems of equations. So your homework is to go solve them, right? Some of them we solved already. Do you agree? And some of them we did not. Some of them I said, okay, that's easy. Now go finish it. You're supposed to be doing what? Finishing them. Do we agree? That's what your job is. All right, what? Well, I don't even know because we have a huge break coming up. So to be honest, I'm not sure we're going to have a quiz on this because we're going to have a week off. All right, so I haven't made up the lessons for when we get back. Okay, so I'm just telling you, you're going to submit this. Remember when I said that AMC is going to be tied with something else? That test we took. So I may just do this. So I'm saying do a really good job, all right, on this. All right, make sure you're writing things out, labeling things, doing what I'm doing. If you need a picture, draw a picture in there. It'll help. Yeah. Just you can stop at 25. Tomorrow we'll do 26, 7, 8, 9, and 30. I think the last 5. All right. Good job today, guys. Really. Hopefully, it's starting to make better sense.